morning, everyone, and welcome to Proteins Live with Nutrition Period 2.
Thank you so much for joining us today. Today's topic is protein structure.
Proteins have a variety of structural functions, and today we're going to see what they are and what they do in your body.
Yes, proteins are indeed complex. They are the most versatile macromolecule in living systems. So today we're going to talk to some experts about proteins. Every lucky audience member should check under his or her seat to find a free proteins program and help them follow along with today's show.
Our first expert is Dr. Jillian Lindenberg, an expert in protein structure.
Let's give a warm welcome to Dr. Lindenberg.
Thank you so much for having me. It's a pleasure to be here.
Thank you so much for joining us.
So let's start off with the basics of this complex structure. What do you think is the first thing our viewers should know about proteins?
Well, proteins are extremely complex, but viewers should know how they accomplish all the things that they do.
Okay, now correct me if I'm wrong, but aren't there 4 different levels of protein structure?
You're exactly right. The 4 levels of protein structures are primary, secondary, tertiary, and quaternary.
And what does each of these structures do?
Well, the primary structure is simple, a linear sequence of proteins' amino acids. The structure has an amino terminal and a carboxyl at the end.
Now, secondary structure is the next, correct?
Yes. Secondary structure is compressed of folded polypeptide chains. There are 2 different types of secondary protein structures, alpha helix and beta sheets, which are located at the core of the protein.
And the third type of structure?
That would be tertiary. Tertiary structure is known as the 3D structure of protein, which entails the shaping of the secondary structure. Tertiary structure is held together by disulfide or ionic bonds, or hydrophobic and hydrophilic interactions.
Wow, that's a lot of info, but isn't there even more? Can you tell us about this 4th type of structure? What's it called?
That would be quaternary structure. Only some proteins get to this level where 2 or more polypeptide chains join together to form a protein, sometimes with an inorganic compound as well.
Okay, so now that we know how proteins are composed, let's talk a little bit about what exactly they do in our body.
We have here with us nutritionist Paige Van Buskirk, who's going to talk with us about the many different functions of proteins.
Please give a warm welcome to Paige.
Welcome, Paige. Thank you so much for joining us.
Thank you for having me. It's a pleasure to be here.
So, Paige, let's get right into it. What should we know about protein functions?
Well, the main thing that protein structure helps with is general strength. The structure helps to build, replace, and maintain tissue.
So they keep you strong?
Exactly. Protein structure not only makes your muscles strong, but also keeps your hair, skin, and nails looking and feeling healthy. Protein structure is also valuable in maintaining cardiac health.
Now, what's the relationship between the structure that Jillian told us about and these functions that you just told us about?
Good question. That's really important. To start off, the 3-dimensional conformation of a protein muscle is determined by its amino acid sequence. The folded structure is stabilized by non-covalent interactions between different parts of the polypeptide chain.
Now, since proteins are made up of amino acids, what is their role in this?
Well, the amino acids with hydrobolic side chains tend to cluster in the interior of the molecule. The local hydrogen bond interactions between neighboring peptide bonds give rise to an alpha helix and a beta sheets.
And what is the purpose of this structure in the body?
These different structures help strengthen organelles to repair and form strong muscles.
So now, back to Dr. Lindenberg. You're experienced in this area as well. Can you tell us a little bit about how proteins form these functions that Paige told us about?
Absolutely. Well, because proteins are already present in the body and new proteins effectively replace the missing and damaged proteins, this process fills in the amino acid sequence.
That's very interesting. Now, what are some examples of structural proteins that us and our viewers may be familiar with?
Well, in general, structural proteins are fibrous and stringy, and their main job is to provide support.
Exactly. Some examples of these are keratin, collagen, and elastin, which I'm sure many people have heard of before.
And what are the roles of these examples?
Many viewers may have seen collagen when looking for makeup or lotions. It, along with elastin, provides support for connective tissues like tendons and ligaments. People may be familiar with keratin from the popular keratin hair treatment. Keratin's purpose is to strengthen protective coverings over such as quills, feathers, horns, beaks, and of course hair.
Now, Jillian, can you tell us a little bit more about the science of these proteins?
Sure. We'll start with collagen, which has a backbone of 3 chains and includes the major amino acids of glycine, proline, and arginine. Each of these 3 chains coil themselves, and there are hydrogen bonds that form between these coils. The size of these hydrogen bonds is approximately 1,000 amino acids long, and this is what gives the collagen structure strength.
And is elastin structure similar to this?
Elastin structure is somewhat similar because all proteins are formed of the same 20 amino acids. However, there are some differences. Elastin has many fibers, or monomers, which are linear chains composed of folded hydrophilic acid segments that alter with hydrophobic ones. These amino acid groups in the hydrophobic segments of adjacent monomers called lysines that form cross-links with each other and turn the fibers into a large and inseparable network.
Paige, can you tell us about the keratin structure now?
Sure. Keratin consists of many fibrous proteins. It is also the key structural material that makes up the outer layer of skin. Monomers of keratin gather together in bundles to form structured, unmaterialized tissues, which helps maintain their strong structure.
Wow, what great information. Thank you so much for joining us here today.
Thank you for having us.
It was a pleasure to be here.
We hope to see you back here soon. And thank you to our audience and our viewers on our last episode of Live with Nutrition Period 2.